live from New York, it's Ask a Bunch of Engineers.
Hey everybody! Wow, it's a party here at the Adafruit factory. We're broadcasting from our factory here in downtown Manhattan. So we do all the design, engineering, shipping, manufacturing of Adafruit goodies. And today we have some special guests from our friends in New York, GoTenna.
Yeah.
Hello.
Quickly introduce yourselves.
Quickly introduce yourselves.
I'm Raphael, hardware engineer.
Jen Chen, RF engineer.
And Danielle, I co-founded GoTenna. Not an engineer, but I like hanging out with them.
Company engineer.
Yeah,
You built the company.
engineer.
You built the company that counts. And they're going to be our special guests today. We're going to start off with some Adafruit stuff, and then
That's
we're going
right.
to talk to them tons about RF and their new
Yeah.
Kickstarter and what they've been working on.
And this isn't the first time you've been on the show.
No.
No, we were here almost a year ago with our first product.
Yeah.
And now we have mesh networking.
So for all of you out there, look at the previous GoTenna video because I had a little bit of Maker past. You helped kick off the Maker revolution with your open source MP3 player.
I love it when you say these things.
It's absolutely true, and not a lot of people know that. So, and I went into that. Watch the previous one because I didn't want to do the whole thing again. Like, hey, remember we met each other in San Francisco, and you did this open source MP3 player, and it really kicked off the idea that people could make something that normally wasn't DIY. Lamore had also done that. She made the Minty MP3 player, and if there was ever a book about open source hardware, because you're doing other things, and people don't necessarily put everyone in the spotlight, you were one of the one or two people out there that was doing open source hardware from the start.
I didn't even know what it was.
Yeah.
Yeah.
So thank you so much because it's been going on for at least a decade since.
Yeah.
So,
Yeah, 2001 was when I started walking around at this.
This thing's happening.
yeah.
Yeah.
And you look identical. I don't know how you pull it off. Okay.
It's, you know.
Good
Yeah,
skin.
I have a special painting in the basement.
Looking good.
It's
you
a
know-
PCB painting.
Dorian Gray jokes are always okay here.
All right.
All right, so let's get
kick it
started.
off.
Yeah, so the code tonight is GoTenna. If you want to support Adafruit, buy some electronics, 10% off. The code is GoTenna all the way up to 11:59 p.m. Eastern Time tonight. It's 10% off except for gift certificates, software, and AdaBox, our new subscription service. We're going to have the show and tell, notes from Lady Ada, who is on the show and tell, mailbag, a little bit of time traveling, look in the world, back in the world of makers, hackers, artists, and engineers, new products. We're going to answer your question. We're going to have a trivia question, all that and more on, yep, you're still here. It's Ask an Engineer.
Okay.
All right, so a little bit of biz. Every Wednesday we do show and tell 7:30 p.m. and every Wednesday we do Ask an Engineer. We still have our UPS ground shipping going on for $200 or more in the continental U.S. and in Manhattan. If you're checking out on the site before 11 a.m., you'll be able to see same-day delivery options.
Ooh.
So yeah, if that's interesting to you, go for it. Lady
A lot of
Ada.
students and media people do that.
Yeah,
That's what
last
I
minute NeoPixels. Okay, Lady Ada, show and tell.
Okay.
Which we've been doing for 6 years, I think.
Yeah.
now.
All right. We had a really fun.
yeah.
A lot of new people this week for the show and tell. Start off with Adafruit Southeast peeps. Noe and Pedro, they're getting ready for a hurricane. That's going to hit them. Hopefully, it won't be too bad. But in the meantime, they've been designing up a storm, as it were, with a UV brush cleaner that they're going to be showing off next week. So they just previewed this. It's for makeup brushes, but also could possibly be used for other kind of brushes or tools. It dries and sanitizes using UV and a fan. And then Scott S., who is from Adafruit West, Northwest, had got USB mass storage working for the @samd MicroPython build that we're working on. So you will be able to write code for your microcontroller and then drag it onto the microcontroller as a disk drive, which is pretty cool. So look forward to that. So we just got it working with the internal storage, and hopefully we'll have it working with external storage like SD card or SPI flash soon. Chris Young came by and visited, and he actually was showing off, he wrote Pavre, in 1995, and so he showed taking one of his first renderings from Pavre and exporting it to a 3D mesh that he could then import into MeshLab and then ray trace, the way he ray traced it so he could 3D print it. It was a very interesting analysis of how you take something from a ray tracing program and then you export a mesh. Before there was, at the time, there was no such thing as 3D printing, so why would you export a mesh? You wouldn't be able to do anything with it. So kind of re-adding that capability by ray tracing. And also a shout out to, what's his name from, who was at Maker Fair?
Adian.
Adian, who talked about democratization of 3D printing and technology, which Chris Young uses to help make his accessibility tools. So that's really cool. And speaking of ray tracing, we went next to Ray, who made a Maximize Overkill controller for 3D printers. It does has ESP 8266, has Ethernet. It looks like it has like some huge, like maybe it was an at Mega 256. That's pretty popular for 3D printing firmwares. It runs smoothie. It's got 6-axis steppers, 6 end stops. You can change out which stepper driver you want. He just said it was Maximize Overkill. He's going to get 100 of them. So if people want one, check the link for the show and tell because you can pick one up. They look pretty Maximize Overkill. I hope that's the name of it, just Maximize Overkill.
Yeah.
That'd be pretty nice.
That was a Maximum Overdrive. Was
Overdrive.
that trucker movie that was from Stephen King and the trucks went alive? It was like an Internet of Things.
It had like a clown face on it.
Yeah, it was like an Internet of Things movie before internet.
Yeah.
Yeah.
3D printers. Okay, and then
Yeah.
Lon came in, just showed his work on the foam weapons that he's been doing. He had a dagger with jewels, he had a pirate saber, and then he's making a gigantic BlizzCon sword that he's going to take us from World of Warcraft. It's like a gigantic sword. I don't know, maybe I don't even know what side he's on for World of Warcraft. So, but it looked pretty epic. So he just had the plan cut out, and he's going to do the foam work. And I know he does Twitch streaming of his cosplay, so check that out. Andrew came in, and he has 2 projects. He showed the first one off, which is a Tempest 2000 clone, but written for the Oozebox, which is an Atmega 644 game controller console, DIY console called Tornado 2000, and it was like pretty cool. I mean, it was basically like drawn version of Tempest. So if you want to have Tempest but without the special CRT monitor, you could build this. And then another Scott, he's working on a costume for his son. It's a Bastion costume from Overwatch, and so he's making the gun, and he like cracked it open. It looked like it was like a Nerf gun that he'd been modifying to add a power boost, a Trinket Pro, a sound effects board, so it has sound effects. And he also not only added the trigger sound, but the ultimate, like you have an ultimate attack.
Yeah.
So he added that effect too. It sounded really cute. And then Byron had
Did Maker Charades, and he showed it was actually spooky.
Very spooky because it was like silent.
Yeah.
And it was like kind of shaky.
Silence of the Pumpkins.
Silence of the Pumpkins. There was some
It puts
3D.
the pumpkin in the basket.
I think the pumpkin is the basket.
Okay.
He put the NeoPixels inside the pumpkin with his 3D printed pumpkins and other Halloween effects. And then Barry also had a pumpkin. Actually, there was like 4 other pumpkins in the background for people. People love to make LED pumpkins. So he made a 3D printed hatted pumpkin. It had like a kind of a witchy hat on it. And it was fully 3D printed, and then he put a trinket with a power boost and NeoPixel ring inside, and he made like kind of a flickering light effect, which is nice because you can just leave it out. You don't have to worry about like having candles. Like eventually people are gonna look back and be like, I can't believe you guys put candles on trees or like candles out of pumpkins and you just left them out. Like that sounds so dangerous.
Why weren't they internet controlled?
Right, so now
Like
they
that truck.
are, and that
Okay.
was the show and tell.
Okay, all participants on the show and tell get an As Seen on the Show and Tell sticker. If you're on the show, email us, support@adafruit.com. We'll send you out one. Okay, go back. This is Packet. Packet delivers them. So people send us
I'm a
emails. We read these at our weekly meeting called State of the Fruit. You probably have like an antenna, GoTenna broadcast. What do you call your company meetings?
That's a great question. I don't know that
Monday
we do.
through
I think
Friday.
we call them like all hands.
All hands.
/ everyone just
All
come here
in-
quickly right now.
All antennas.
Oh yeah.
All
We should go
tennis.
for something like
Yeah.
All tennis.
Let's mesh.
That's a good one.
Okay.
That's a good one.
mesh,
All right.
mesh meat.
Okay.
Okay,
Well,
but our
this is
letter-
the email that a customer sent in. Adafruit has always 1,000% been, when it comes to customer service, please pass this along. My thanks to the head honchos. So
Scott.
that was from
That's
Scott.
not the Scott that works for us though.
No.
I think, which is good.
No. So thank you, Scott.
Thanks, Scott.
Next up, time travel. Okay, let's gonna spend a couple minutes on this before we get to the GoTenna stuff. So look back in the world of makers, hackers, artists, engineers. I already mentioned that Raf is here. So 12 years ago to the day, I started a site called Hackaday.
Oh.
Yeah. So on our
So it's all your fault. None of it away.
A lot of things are my fault now. There was a Hackaday celebration 2 years ago for the 10th anniversary, but I'm still counting years. So that was 12 years ago. So when you see things on the internet that have hacks and projects and more, much like when I met you, there wasn't a place for this, and that's why I started the site.
I didn't know you made that website.
Really?
Yeah.
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 Now you do.
But
That's like the first thing he says. I mean, it's
No,
black
it's-
with a skull,
I didn't
you
know
know?
that.
It's I did a bunch of stuff.
It's a good website.
Yeah,
I like Hackaday.
Good
It's
work.
fun. It's had up and down with comments and all that. The Hackaday Prize is really good. The IO stuff. There was just a Hackaday event for assistive technology. I have nothing to do with the site, so it's like watching my kid grow up now. So
Oh, yeah.
12 years old, yeah, it's like on its own.
And sometimes the Hackaday site is kind to Adafruit, and sometimes it is. I'm like, but I've been raising you. So that.
I hate you, Mom.
Yeah.
Slam the door.
So that's it has the DNA of a lot of the things you see with Make and Adafruit, publishing and celebrating people. That's the goal. So I'm probably going to do another video about Hackaday, like 12 years in. Like, what are some of the what is the state of the electronics? So that's a birthday. So that's a.
Congratulations.
Yay! Congratulations, Hackaday, for surviving.
Yeah. It's not gone. Same
Yeah,
logo.
it's still around.
It's not a funeral.
I made that logo in Macromedia Flash, and I feel really embarrassed that I use Flash as a design tool. But
There's no shame in that.
yeah, and then I found out today that people still use Shockwave Flash.
I literally use Keynote to the first GoTenna ever physically designed, not like
Yeah.
like the industrial design. I did it on Keynote.
Yeah, I mean, like
Which is
whatever.
like not even Photoshop.
Yeah,
I mean,
whatever though, right? Like
yeah,
it actually works pretty nice.
whatever works.
Microsoft used to design their new OSs in PowerPoint. They would do all that. These PowerPoints were intense because it would pretend to be the OS, and that's what they would show. Yeah.
So it was interactive. It was
Yeah.
moving.
Whoa.
Yeah.
Whoa, that's too much information.
Yeah, I worked on some of those a million years ago, and it was like it was called Longhorn. That was the
Yeah,
OS
that's
that was
pre-Vista, I
yeah,
think, right?
pre-Vista, and I was someone doing graphics, and I was like, wow, this is like an OS in PowerPoint. So yeah. Anyways, yeah, I know. Okay. So next up, I don't know if you knew it, but
What's happening this weekend?
well, it's Open Source Hardware Month. We are an Open Source Hardware Association supporter, and there's an event in Portland. So you'll hear about that, a bunch of stuff. We have some Adafruit stuff, people going out, but celebrating open source hardware. So again, look what you've done. It's still going on.
Good job, Raph.
Yeah. Okay. So that being said, it's time to introduce y'all. So maybe talk about the company, because
Sure.
I have a couple screenshots here. On
Yeah,
the site.
so you're looking right now at our first product. So we started shipping that first product after almost 3 years of working on it. But that device is GoTenna, and it pairs to your phone over Bluetooth and allows you to send texts and GPS locations over great distances over VHF public frequencies. 2 watts, and it allows you to communicate when you don't have service. So you're able to create your own networks when you're out hiking, traveling, a lot of emergency preppers like us. But it's also been used by public safety organizations for disaster relief in places like India. They're being used.
How far does it go? Because
So the first
2 watts must be
right,
pulled
2
on
watts
that.
VHF. So we like to say that you're usually going to get up to 4 miles in the outdoors in like an uncongested terrain, but you can get a lot more with line of sight, of course, and altitude. So
Yeah.
actually, our record, somebody said it is 27.7 miles.
Wow.
So,
did
but that's
you do
not
that
common. I think one of them was on the top of a mountain in like
Yeah, Mountain
outside
Mountain,
LA,
yeah.
and then someone was down in a valley.
Oh, okay.
Oh, cool.
Yeah.
All right.
That
So,
wasn't the skydiving stunt?
so that was our first. No, someone else was skydived.
Wait, I have a question. With VHF, is that? It's been a while. Can you bounce that? Is that tropospheric bounce?
We'll have our RF engineer
Yeah.
answer that question.
You can. The frequency is low, so the wavelength is
Yeah.
long. It's not all the way down into the CB bands, but the distance is probably not long enough for you to bounce really. All RF energy reflects, but probably not off the atmosphere. So that's what you're asking.
Yeah. No. I mean, I know that there's like some tropospheric ducting you can do, but some frequencies at some, people can do like long distance.
It's like
Yeah,
10
those
megahertz or
are
something,
very
right?
much
That's-
higher power
You
too.
guys are at like
They're
150 megahertz,
151. Yeah.
which is still pretty low.
Yeah.
Yeah, these days.
But,
Yeah.
but our power is much lower, right?
That's
The
true.
CB bands, they can go up to 40
Okay, so
watts.
basically, but like line of sight, you can do up to 27 miles.
So far.
If you're in LA and you're really cool,
Yeah, and you really want to try.
and you have like cool glasses on.
Right. So that's the first product, and we talked about it and Ask an Engineer about a year ago. But now our new product we just launched last week on Kickstarter is a product we call GoTenna Mesh, and it is the first totally off-grid, totally mobile, meaning no fixed points, long-range, consumer-ready mesh network. And so it basically can do everything the first one can, except it operates on 1 watt UHF because we're allowed to mesh on those frequencies, and we can sell it to 49 countries as opposed to our first product, which we can only ship to the US because it's only licensed for use in the US. It works everywhere. We just can't sell it everywhere. And so what we're trying to build here is, communication that actually gets better the more people join the network, which is something that's not inherent with, centralized connectivity. And these two guys, so Raf is, working mostly on the digital side, right? And you're working mostly on the analog side, so RF, but both hardware engineers.
Do you sit next to each
on
other?
GoTenna Mesh. They sit next to each other.
Actually, we do sit
Yeah.
next to each other.
There's a lot of overlap. Yeah, we work together on a lot of things, and
So this is a totally new product. So it's not backwards compatible. This is like totally fresh.
Yeah.
It's different. Unfortunately, it's different frequencies. One's 900 megahertz ISM band. The other one's 151.
Are you using LoRa or are you using your own?
We're using our own FSK.
Okay, FSK. All right. Why not use LoRa?
too slow.
We're trying to do mesh, and actually, LoRa's sensitivity decreases if you send too much data through it. If you transmit very, very low
It's
data
good for
rate,
chirps, little chirps.
Exactly. The
Yeah.
benefit of LoRa is basically you get a what is it? It's a spread spectrum. So you get you're allowed to transmit at much higher power without doing anything special. Right? If you transmit 1 watt, you either have to do some type of frequency hopping or wideband modulation. But with LoRa, you get that for free. It's come with the protocol. Now, if we do apple-to-apple comparison at just do FSK, LoRa can do FSK, then just using the radio we selected has equal amount of sensitivity, and we can pump at the same data rate. We are either as good or better.
Oh, great. Yeah, I mean, you're probably going to answer that question like 10 times a day.
Yeah.
Well, and also, since we're focused on burst communication, so we are focused on sending, asynchronous, generally, technically speaking, delay tolerant communication. That's a design choice that we made. We started as like a minimum viable product. We're going to focus on, short burst data comms, but now it's become something that we feel like philosophically attached to, because as a result, we can make the device smaller, lighter, less expensive, and moreover, mesh scalably, which has never really been done without, central connectivity outside the military. And the only system that we know of that can mesh totally off-grid, totally mobile, long range is a tactical radio system only accessible to military users that costs tens of thousands of dollars and the size of a backpack.
Yeah.
So, whereas GoTenna mesh fits into the palm of your hand and weighs 1.7 ounces.
But is the tactical backpack one, is that mostly because of the battery? Because the problem with mesh networks is the secondary to the edge nodes are the ones that get hit so hard.
Well, you can probably speak more to that, but my understanding is that those systems try to do everything. They're trying to do like real-time meshing of high bandwidth media, real-time media. We're focused on text and GPS, and of course, all media is ones and zeros if you break it down. So you could, using our protocols and our new SDK, which is publicly available as of last week, build. You can send higher bandwidth transmissions and just reconstruct it at the other end.
I'm totally going to send like super dank memes over mesh network. Okay. All right, cool.
Well, I learned what that means last week.
Good.
Yeah.
Well, do you want to answer some questions about some stuff now as we?
Yeah, we'd love to.
Yeah, and then we'll do some demos.
Sure.
Okay.
Yes.
Well, let's take care of some of these right now. So one of the comments. So for instance, you were at a festival in the desert. Can you keep a group of friends connected using this?
Yes, we have been used in everywhere from Burning Man to conferences to yes,
Okay.
that's absolutely what it can be used for, and our first product could be too. But now with mesh, you're able. Let's say Raf is trying to get a message to you, but you're out of range. His message can go through us automatically and privately because of our mesh protocols.
Okay. Next up, 151 megahertz. Is that correct?
That's the first
Close
one.
enough.
No,
That's the first product.
That's the first one. And is the first one line of sight?
It doesn't have to be, but obviously that helps.
Okay. And then the second one is which megahertz?
900. It's the ISM band. In the North America, it's 902 to 928. In Europe, it'll be the 863 to 870. There's a small 250 kilohertz band we can transmit half a watt. That's what we're going to use. And that's it.
And what is that band currently being used for?
It's a ISM, industrial, science, and medical. So it's free band. It's unlicensed band. Anyone can use it.
Yeah, that was the next question. Do you need a license? As
You don't need
manufacturers?
license, but you have to meet FCC rules. As in,
Right.
Everybody does.
Yeah.
Everybody who uses that
Any
band has to.
intentional transmitters, right?
Exactly. You have to transmit only at a certain level, like 1 watt. We would love to transmit higher power to get more
Yeah.
range, but 1 watt is the limit.
But just to clarify, users don't need a license.
Yeah.
We, GoTenna, go through the
Yeah.
certification and regulatory process, and our devices have
Yeah,
licenses.
the person
Right.
doesn't have to be FCC certified.
No, no, it's really annoying. So
Yeah.
It's like using.
we do it for you.
Yeah. Does anyone need or have a ham radio license? Does it have anything to do with that, or is that just
Completely free,
Gotcha.
unlicensed.
Okay. All right. Next up, how's retirement? Did you retire? Does anyone remember? I don't know. Yeah. Okay. Does it transmit encrypted or in the clear? I think maybe because of the Kickstarter did so well. I don't know. Maybe that's what they're at. Does it transmit encrypted or in the clear?
It's encrypted.
So you're able to send different kinds of messages. You can send private messages, and you can also send something which we call shout, which is basically a public broadcast shout. So the the shouts are by definition public,
Okay.
unencrypted. But the others are end-to-end encrypted. We use 384-bit.
I think the
Other guys know that. I have no idea. It's something fancy, and they are
With public-private key ciphering.
Okay.
they are paying attention to what's happening.
So when you
with
hang out with
it.
your friends, you touch phones or something, and you're like, hey, like this is their key, and you do a key exchange, and then later on,
Right.
you can connect through.
I believe all the messages are encrypted. It just it's a feature in the app UI. You can do a shout, so anybody with GoTenna device can receive that message. But the actual message itself, over the air, if anyone sniff it, it's actually encrypted.
I don't actually know how the key exchange works.
Yeah,
but
we are
I'm
not the
sure
firmney
it's-
engineers doing
Okay.
that.
Yeah.
But
Well, you have to meet the person ahead. You have to know ahead of time
yes,
who you want
you
to
add a
talk to.
contact the same way you do in like a normal, like the only way through iMessage or WhatsApp or whatnot that you're able to send a message specifically to Raf is because you have his phone number,
Yeah.
right? And then and it's the same thing. You know the process. You have an ID that's associated with your phone and your device that you verify, and you can have that be your phone number,
Okay.
which most people do because then it integrates your contact list. Or you can create an anonymous ID that's randomized and that you just have to like physically share with somebody.
Yeah,
Okay.
and then because we have very security focused folks who watch the show. Is this something that a man-in-the-middle attack could like? This is the thing it always comes up.
So we actually, this might be a little bit out of the scope because I don't think any of the three of us here are really encryption experts. We do have people who are,
Yeah.
and also we have a really, really wonderful, responsive, and patient person who answers questions, who works with us. His name
Gotcha.
is Noah, and he will definitely, if you have any kind of questions like this, he'll
You want to defer to him, yeah,
he
because
will
he's
tell
going to
you
know the
what's
answer.
happening.
No, I know because the answers are
I
always
don't
very
wanna-
specific. It's
yeah.
like, well, in this particular incident.
I don't want to lead you astray because I don't think any of us. I don't know.
Well, I know
Genuine
that I know that
public.
a lot of people on Twitter ask about man-in-the-middle attacks, and so what I can say to you is that the messages are over the air are transmitted like encrypted,
Yeah.
and the only person who can open the message, even if it relays through one of us in the mesh, like we can't open it, even if we could stop it.
Oh, is that
right?
what that means, man in the middle? Yeah, no.
But
it's got ability
but
to go over
and the
air.
only person who can open a message is someone who has the key that can decipher it, right? So
Mm-hmm.
even if someone could stop the message, with like something in the middle,
Yeah.
which you'd have to be very close, in which case you probably have other problems
Yeah,
you don't want
you'd
to
see
worry
them,
about.
you're
Oh
like,
my
"Hey,
God.
Then it would be garbled, and we use end-to-end 384-bit elliptic curve. We use, I'm pretty sure, Bouncy Castle and some other things that I can't remember right now. But
Bouncy
it's all
Castle.
like we're not an encryption company. We're doing the best that we can using open source. We are an ad hoc
I'm not talking about
reconfigurable.
Bouncy
I
Castle.
think Noah's lying to you about the bouncy castle.
All of us want to know what that is.
Yeah.
Bouncy Castle? It's
Yeah.
it's like it's an encryption open standard.
Oh, neat.
They're finally giving them
Cipher.
good names.
Okay. And then before we're doing good on time. Before we get into demos, so someone had mentioned that y'all did an excellent overview of testing antennas. Like you had a blog post, or you showed, or you talked about how you did testing of this stuff.
We may have, or may have
I
been
must have-
an interview or something. Yeah, I
I
don't
must
know.
have written a blog post about it, but I'm
Yeah.
I have no memory of this.
Yeah.
Was there a specific question though?
Yeah,
I'd
I
love to
think
answer questions about
Caleb
that.
had said you did an excellent write-up about antenna testing.
Well, great.
Yeah.
I'm
Good
glad I
work.
did that.
You did that. Good work past you.
Sorry, Caleb. I kind of forgot.
Yeah, you must have wrote something about it.
Yeah.
So what? So to, just to pivot on that question, what did you do for your testing?
So
Yeah.
for antenna design, so the antenna on the first product was really hard to deal with because it was so tiny and it was so much smaller than the wavelength that we were broadcasting. It was about like maybe 6 inches long, and it's a 2-meter wave, which is like 6 feet. So you've got a big problem there. We did all kinds of crazy stuff. I ended up making a deliberately detuned antenna that I put really close, even though there's a lot of near-field interference. It was the only way I could get around all sorts of multipath interference in the office because we don't have any way of taking these things outside. So it wasn't a great way to do it, but it was the only way to do it in New York City.
Yeah.
And it turned out to give good results, and the antenna's tuned really well. Now, the new antenna is a totally different story.
It's so small.
So I don't know if you want to put it on
Yeah,
the
I was going
going
to say, do you want to start showing some
Sure.
demos? Okay,
Yeah.
great.
So
That's what everybody's here for.
We had a person working with us who designed an antenna for 900 megahertz,
That's so cute.
and he said, okay, well, if the whole thing is 4 inches long, which this is approximately, and you have a bunch of ground plane here, this is the antenna that you should make. And I printed it out on a printer, taped it to the back of a piece of copper foil, cut it out with an X-Acto knife, and stuck it on a network analyzer, and it worked.
Yeah.
So,
Ta-da!
900 megahertz
Boom.
isn't so bad, yeah.
yeah, it
Just
wasn't
got
so
to
bad.
do that a bunch of times. You got a bunch of backers on Kickstarter.
Right.
So you're going to be busy.
A lot of
Maybe get
X-Acto
one of the
knifing.
Cricut things that cuts out fabric or
Zip, zip, zip,
something.
zip,
Yeah,
zip,
I
zip.
learned how to use a network analyzer kind of recently, and actually since we designed the first antenna. So we hired an antenna design firm to make that for us, but they didn't really do a great job of telling us how to actually make it work. So matching networks and stuff, it was a real trial by fire, but we did get it. This has been a lot easier. We kind of know what we're doing now.
It was in-house too.
Yeah, it was in-house, and we're a different company now. You know, it's like,
Totally different.
yeah, I mean, I'm a different person.
Yeah. Like, well, you step into the river has changed.
Well, also now we have an RF engineer. So now we
Okay.
have someone who
Now it's his fault.
full-time. Yeah.
I don't know.
So I mean, that makes a huge difference.
Yeah.
Okay. Well, before we go to the overhead demos, I'll ask more of a company questions. How many people are you now?
We are, I believe, still just shy of 20.
Okay.
But we're hiring. If anyone wants to work on embedded systems, in
Oh,
particular,
yeah,
visual
these fun people.
designers.
Yeah.
Visual designer, I think, is open. I think those are like the two
Okay,
big
so go
ones.
to GoTenna.com.
We need a
Yeah.
firmware engineer pretty
Bouncy-
bad.
GoTenna.com/jobs.
Bouncy
We are
castle.
hiring. Brooklyn.
For
It's
firmware
fun.
engineering, what's their expertise? What should it be?
Somebody who is comfortable with really low-level stuff, right down to the metal. You need to know what the registers are and what they do. Not like every single one, right? But like within reason. I'd like somebody who's at least familiar with open source concepts, even though that may not come into play that much, and is comfortable writing in C.
Okay. All right, demo time. Show some
Okay.
stuff.
I mean, you mentioned open source. Is any part of this open source, or do you have an open API?
I just use open source as an indicator of a person that I'm going to find enjoyable to work with.
Okay.
Yeah.
that's
So.
cool.
We do have an open SDK that we released last week, and you can build anything on top of it. So we already have people who built sensor monitoring for like elder care, so they know like when a machine goes out and someone, an elderly person's home and they live alone. Someone else built like a search and rescue application where they built kind of like a God view where you can automatically track any other GoTenna mobile unit. So it's sort of like a command
And this
center
is part
view.
of because you have the higher bandwidth of a 900 megahertz connection.
That
so-
actually, those have all been built on our first product,
Okay.
the one that works on VHF frequencies on 151 to 154 megahertz. But the SDK applies to our new product once you get the hardware as well.
Okay.
So you can build anything on top of it. Think of GoTenna as a really unique, totally off-grid, long-range data link that you can do anything over.
And for the 900 megahertz version, what's the distance on that? It's not going to be 27 miles, probably.
Right. No, probably not. We haven't gotten those same people who want to go break that record. Of
Yeah.
course, the product is still not in their hands. But we are saying that where with the first product, it's 151 megahertz, 2 watts. We're saying usually up to 4 in the outdoors. With this one, we're going to say usually up to 3. But it might do better in certain other scenarios. Do you want to speak a little about the RF and the different properties of the different frequencies?
Yeah.
Sure. In the end, really a link budget game. There's something called dB, decibel, in RF, and the total distance really comes down to how. A good analogy is like what we're doing right now. I'm talking to you.
Hi.
And, hello.
You have very high gain in this direction.
And the voice, how loud I'm speaking is the transmit power, and how sensitive your ear is the sensitivity. And in the end, radios are defined that way. It's how high you can transmit. In this case, we only allow 1 watt, and that's due to FCC rules. We love to transmit higher power. And then how sensitive our radio is. And it's a link budget thing. In total, I think our sensitivity is somewhere around range about 139, 140 dB. And then just compared to the first one, we're transmitting at 2 watts with 3 dB higher. I think the sensitivity is about equivalent. right?
This one's going to have a little bit better sensitivity because we have a lower noise figure in the noise figure, yeah, in the front end on the LNA. So just higher quality parts, I think, is going to help.
So in the end, difference is about 3 dB, and 3 dB is in absolute terms half the power.
Okay.
So that's the difference. But the way our RF works, rule of thumb is 3 dB you lose about a quarter of your range, basically. That's what we're saying.
So you lose 1/4, so it's about 3 miles.
But you could make it up by meshing through others. You can double or triple your range.
Yeah,
right?
no, I mean you could go across the United States. That'd be really
Over
funny.
time, we're gonna walk before we run with our mesh protocol. It's the first
Yeah.
of its kind, so we want to make sure it's not just something that remains academic or theoretical. This is something you can use for real.
No, mesh is hard.
But over time, our protocol will become more cognitive, more intelligent, and do different things in different situations.
Yeah.
And then, like you said earlier, it's all about what type of obstacle you have. If it's line of sight, then the energy can just travel directly from the transmitter to receiver.
Yeah.
But you have buildings between, then you have to find its way across it. Like when I'm talking to you, if I put my horn on my mouth, then the entire message is kind of blurred. And the lower the frequency it is, the more attenuation. Higher the frequency it is, the more attenuation you actually get by different objects. Just imagine the waves length a little bit smaller, so more stuff start to matters. So it's highly dependent on situation and setup.
Yeah.
But if you line of sight, you can see each other. You can go very, very
3 miles is pretty good though. I mean, line of sight, that's good.
I was using it when we were filming our product video, which you can see on our Kickstarter page in Seattle over a month ago. I was getting pretty equal performance between both our V1 product and our GoTenna mesh prototypes, which were even less efficient than they are now because we've been making tuning changes and whatnot. They both got over 3 miles in a certain line of sight situation.
That's cool.
Yeah.
All right, sweet. So let's look at some prototypes under the overhead.
Everybody's here for the hardware.
Yeah, we're here for the hardware.
Yeah.
What is this?
So I learned the lesson the hard way. When we did the first ones, I didn't really do any development boards. I just kind of went straight for it, and that was stupid. That was just stupid.
No, you learned something though, right?
Yeah,
Which is not to do what you did.
I unstupided.
It's
Okay.
a learning opportunity.
Yup. So I made some development boards for us. So
Okay.
we call this our little digital board. And there's a Bluetooth connector here for a Bluetooth chip, because we were trying to figure out which one to use. We ended up going with a NRF, the new 52 ones, which led us to the more recent version of Bluetooth. And then we made these little duck subboards here.
They're so cute.
Look at that guy.
Hi.
It's kind of a little, it's a little turkey.
I'm a
And-
turkey. Turkey? I guess so.
I'm
maybe?
just looking at the tail feathers.
Okay.
So, and the 2 heads.
Yeah, that's
Yeah,
common with
typical
turkeys.
turkey.
Typical turkey.
So this is an example of, like a radio board with all kinds of little attempts at different sorts of functionality here. And it's got the pins and it sticks together. So, we kind of made our own little ecosystem. Here's one where I was testing to see whether or not this thing would survive just running full power, whether it would get too hot or whatever. So I stuck a chunk of metal on here, which I figured would be about as much as the surface of the heatsink, and I made it worse by covering it up part way. And then we just ran it and looked at it with a little thermal camera, and it was fine.
Oh, cool.
So lots of little tests that we could do on a large scale. And then, you have any questions about that one?
Well, no, I'm just looking. So this is just your main processor here, and then what's this?
That's
Some
the flash chip.
Yeah, it's a flash chip.
Sadly huge. I don't know why
I
those
know.
things are so huge.
I don't know why they're so big. You can get them either in like 2x3 BGA or WSON or SOIC, but that's it. For some reason, SPI flash is just like SOIC.
Yeah.
There's just a standard.
It's a big pain in the ass.
JEDEC, and they're the wide ones too. They're like fatty style.
And so slow.
And so slow.
But-
well, you can get like 100 megahertz SPI flash. Okay, so you get the
So
microcontroller.
this is a Freescale chip.
Yeah.
So we moved up to an M4 with a lot more RAM and a lot more code space.
Yeah, that's good.
But what's funny is we've offloaded a lot of what used to take up our code space because most of the Bluetooth stack now lives inside of
Right, because you're not using the
that
RF
other Bluetooth chip.
8001 anymore.
Right. So 8001 required a lot of babysitting by the CPU.
But the NRF 52 has a Cortex M4 in it.
It does, but it doesn't have enough RAM for our networking layer. So too bad.
Damn.
Yeah, we need
That's
like
nice
8 times the amount of RAM that they put in there.
Rough.
Yeah, that's the way it goes. So it's okay.
Are you running an
because-
RTOS on here?
Yeah.
Which one?
I don't remember. No, it's a regular. It's a standard one. It's one of the two that everybody uses on Freescale, and the firmware engineer will be able to answer that in 2 seconds.
No, I'm just curious.
I don't know. I'm sorry.
Whatever. All right, so you got an RTOS on here. You got.
There is an RTOS on there, and it's not anything special. It's,
you have something going on because you're doing all this mesh networking and Bluetooth, and you've got it's juggling.
Oh, there's tons of stuff happening.
It's on a bouncy castle and juggling at the same time. It is actually clown RTOS. Mm-hmm. Okay.
Yeah, and there's forward error correction that has to be calculated in the chip that doesn't happen in the transceiver chip. Just tons of glue. Talk to this chip, talk to that chip. All the stuff that these things have to do. It's surprising
and this is
how
where
much it takes.
this is where the messages are stored. The mesh messages. This is where they're buffered.
Yes. So when you send a message to this thing, it immediately writes it to the flash chip, and then hangs onto it there until it's sure that you have it in your phone, and then it has a chance to erase it. That way, if you're not paired to it, or you forget that it's on or something, you still get your messages. It's just that when you pair to it, you'll just get this flurry of messages coming through over your Bluetooth link.
Yeah.
Yeah. That way you don't lose anything.
Okay. So then you add on these little networks. So which radio is this? This is the actual 900 megahertz radio?
So it's actually, we're using the same transceiver chip for both products. That transceiver chip can be
the
tuned.
CC1101?
No, it's a Silicon Labs part.
Oh, that's right, the 4431.
4460.
4460.
Yeah.
Encyclopedic. Wow.
Yeah.
I knew they all start with 44.
50% correct.
Sorry, the RF cat uses the CC1101, but there's also a CC1011, and it's just why did you guys do that?
I didn't like the CCs because the tool set for them is kind of a hassle.
Dude, Scilabs is awesome.
Yeah, so
Okay,
they're really
high five.
cool.
High five for Scilabs. Austin,
Yeah,
Texas.
good job, guys.
Americans.
Oh yeah, Boston? Cool.
No, Austin, Texas.
Oh, Austin. Oh, okay.
Yeah. Some of them are from Boston. They moved to Austin.
'Cause they
Did you know
like
they just bought Blue Giga?
They just bought, they did.
Oh.
Actually, a year ago.
Yeah.
Oh, that's right.
Oh, okay.
Yeah, we're just saying,
Yes.
A lot of okay, sorry, so we're getting distracted.
okay,
So you got that same radio.
Now we, so there's that radio on there, and that radio handles a lot of the just over-the-air stuff. But ultimately, it really just hands us a packet of bits, and we're responsible for making sure that all works networking layer-wise.
Okay.
Okay, so that's this
And then
thing.
you just Bluetooth it back to the phone.
That's right.
Okay.
Yeah,
And this time we're using Bluetooth 4.2, right?
that's right.
So it's next generation Bluetooth LE.
Yeah.
We're doing that
Backwards
because
compatible.
yeah, backwards compatible. So don't worry, your old phone will work. We're doing it because you can get larger data packets faster.
That's right. Yeah, the NRF.
That's really the only reason.
Even the NRF 51 had a limit of 20 bytes per packet,
Yeah,
which is killer.
that's because of the Bluetooth standard.
Yeah.
That wasn't their fault.
Well,
I'd forgive them.
But I want to blame them anyway.
Yeah,
I don't
yeah.
know why. Okay.
So now we've been working on our case, and so
Okay.
I'm going to show you.
Oh, so what year was this? When was this
This-
that PCB? When was that built about? 6
like
months ago, 12?
6 or 8 months ago.
Okay, so that's recent.
Yeah, we've been going way faster.
Okay, fast.
Yeah.
Well, you already know the chip, and you know about
Yes.
Bluetooth. And
Yes. We have a huge
The antenna
library
you can.
of things to draw from and experience.
Yeah. Exacto
So
knife.
we've got a wonderful engineer for all of our mechanical stuff now.
Say hi to Paul.
Yeah, hi Paul.
Hi, Paul.
Hi Paul.
Is this Paul here? Hi, Paul.
And so here's the PCB in imaginary form, and here's our battery in imaginary form, and so you can get a sense of just what's going on inside.
This is really beautiful. What was this printed? It's with a Formlabs, what did you say?
Shapeways.
Shapeways?
Yeah, good old Shapeways.
All right, can we give a high five for Shapeways?
Okay.
Shapeways.
Yeah.
Shapeways is awesome.
So this looks the way this looks.
But check this out. I mean, think
Uh-huh.
of all of this open source and these companies and this modern community that's coming together to make this happen for you. Isn't that cool?
I just want to say the 3D printed versions of cases that we did for our first product were so much crappier than this. Like the 3D
What did you
printing
use?
technology.
What did
I
you
mean,
use?
frankly, we used probably a first generation MakerBot at that point.
Cupcake.
I mean,
But it was still better than.
Oh, it was better than anything
Yeah.
had ever
But
then,
existed before.
sending
And that
it
was
out.
But it's
so much
incredible
better
how
than
much that
zero,
has
which we all had
progressed.
before. Yeah, we
Yeah,
had
before it was
nothing.
you do
Even
it
our
wax.
first 3D printed prototypes, which you just saw the case of, are actually kind of beautiful. You know,
keep them.
and you can sort of tell what it's meant to look like later.
Yeah.
Even early stage. It's
Okay, cool.
Really
All right, so
awesome.
you got these gorgeous 3D printed
Yeah,
cases.
put them under the
Okay.
overlay.
He did. But now he's moving
So-
on to the next thing.
And the
got
inside too.
Little bits and
These
pieces.
are veneers.
Have you
This
have you-
represents the veneer.
Have you thought of picking up a Formlabs, because the Formlabs, they can do this kind of resolution, it's kind of translucent material.
Yeah.
No pressure, but they can do it. They're a little pricey, like $5,000. I think you have to maybe.
But you've
3,000
sold
to get-
products successfully. You have a Kickstarter. You can afford a 3D printer. You can afford a 3D printer, right? Can you tell?
You
Please
can
keep
afford-
talking so I can talk them into letting us get a 3D printer.
Well, here's the thing, actually.
We want to be around for a long time, which means we're not going to spend a ton of money just to spend it. But $5,000 is interesting. And
I'll
so
tell you what,
with
though.
new products, maybe we need a more, better prototyping that.
We do.
I'll think about it.
We have a 3D printer, and we just have a replicator. Although we did.
also
Noah and Pedro
want
have a form. They have an Ember.
Well, you can go borrow. You can go use someone's.
But we
and then see if
use
works
it
out.
all
No,
the
seriously.
time. We use it all the time, constantly. We use
right.
it for our testing
Get
jigs.
some
We use it
stuff
for
under it, 'cause
closures.
this is gonna be boring
like
over here, I don't see
prototyping, like holsters and stuff. Okay,
So here's
what's
what it
this?
actually is going to look like. These are real parts.
I can't
these
touch
are-
this. I'm not allowed to
These
touch
are well, the plastics are made from a mold, so that's actually like real plastic. This is made by some CNC people and costs a fortune. And it's not exactly like that big of a deal, but like we don't want to scratch it. But they will look exactly like that, which is the whole point of these guys. Ah! So
Do you think that was formed, or do you think that was actually seed?
It's milled.
It's milled from
yeah,
one big piece.
somebody look at how nice
I
it
think
is.
probably the piece of like titanium was like this big, and like that's what that comes out.
So the reason that these are pricey is that these are made by a model maker by hand, one by one, because we're still tooling the the
That's so
final
cool.
tools for to be able to make the veneers and the plastic, all the
So
enclosure
this
at
part
scale.
made by hand. That's
is like
amazing.
a-
And it won't be made by hand once our tool's finished.
No,
but
I think it should be. I think there should be like option, like the highest Kickstarter was like it's all like
Artisanal.
handcrafted.
So one of the
artisanal.
things about this, it looks like almost Star Trek Next Generation.
Yeah,
Like
very
that
similar.
like slickness, 26th century, 23rd century.
Good.
Yeah.
I think that's kind of good and also sort of retro sounding.
Yeah.
Oh, you found the heat sink?
It's
Okay,
retro.
good.
It's retro future.
I was like, is this a magnet? What is this? Okay, is this a heat
Yeah.
sink?
There's the heat sink.
Okay, cool.
And there's the heatsink pad underneath,
Okay.
which we may not even actually need, it turns out. And so inside, I have, look.
Oh my
real
God, it's a
circuit
working
board.
PCB.
Yeah.
And it even says
I
GoTenna
did my little reveal here.
900.
So that's a real one. These are basically done. We have made a few minor modifications to this thing since the one you're looking at right here, but you can't really tell the difference.
Oh, and you've got the Skytrack Venus. This is cool.
So to be determined if we
Okay,
need
so
that.
when are you going to do the RTK?
The RTK.
You're going to do RTK capability in there? No. What?
Not yet.
Well, why'd you get the Venus then?
You want to explain?
Well,
It's a
it's
networking
actually
question.
a
That's what-
networking question.
that's
It's a
what I
wireless question. We are a mesh network, and
Yeah.
we're hopping, right?
Yeah.
And when you hop, you want to make sure every device, every node in your system is synchronized in time, so
Yeah.
you can properly transfer the hop properly, so you don't kind of overlap or collide with
Yeah.
other transmissions.
Yeah.
That's why we're looking at a GPS receiver. We do have a very, very accurate temperature compensated oscillator. At
Yeah.
2 ppm.
Yeah.
Maybe could be even better under the room temperature. So
Tough
we'll
because
still
the heat
evaluate
sink is so
in
close,
between.
right?
It doesn't affect it.
Yeah.
Really? Oh, because temperature
And
compensated.
also
no.
RTK, we don't need. It's nice to have, but again, good thing about engineers. There's always saying engineers. Anybody can.
No, because it's
can
just
build
famous.
a bridge,
It's
right?
famous for like this is the chipset that you use for that. So I was like, that's because usually when you see low cost GPSs, you'd see something like a U-Blox or like a MediaTek. So I'm interested in why you went
Yep.
with the Venus.
It's again low cost is probably one of
It's
the
cheap.
main reasons.
Also, just ease of design.
Ease of
This
design,
was
okay.
my first stab at a GPS system, so
That's
I wanted
cool.
to keep the development
Okay.
plausible.
Okay.
There is a chance that the final versions of GoTenna Mesh that go to consumers later this year when we start shipping at the end of the year may not have the GPS chip but we built it so that so that we can figure out whether we do or don't need it because obviously it adds cost.
Yeah,
and,
no,
you
that's
know.
like it's
so
a
so we
bomb.
built it in right now, but it's drop in. So we can also take it, but so we're going to test, our mesh protocols, already implemented, but we will continue to iterate on it forever, including, not just up until when we ship, but thereafter, because we can upgrade
Yeah,
the firmware.
it's a challenge because
and
your phone has a GPS on it
Exactly.
already, and
Exactly.
it has but not all phones have GPS. Also, your phone might the GPS on your phone takes a lot of power. It's an interesting trade-off.
Yeah, again, the main reason for the GPS is we're looking
Time.
at that very, very accurate time. There's atomic clocks on the satellites of GPS, 3 of them on one board, one satellite, and they're accurate to the nanoseconds. That's
Yeah.
why you use it as a time reference.
And you need
That's the main
nanosecond
reason.
precision.
We don't.
quite.
We don't. We
No,
don't.
look, I'm
But
asking.
it comes for free, so we'll
yeah.
take it.
Okay, Right. No, I mean, what's interesting is that there might be, I mean, like, you know, you can have a real-time clock, but like it might turn out that this is smaller, cheaper, and you do have that capability of now you can do GPS hopping. I mean, like this adds a lot of capabilities to this device. This is pretty serious. It's like its own cell phone.
Yeah. It's a lot. We packed a lot into this thing.
Yeah.
Okay.
Which means you
learning
can
so
really use the
much.
SDK to build all sorts of fun stuff.
Yeah.
So-
Base stations,
This is
relays,
fun.
LARPing tools, I hope.
You want me to do the pointy at the squares?
Yeah.
So just
See
a
what's
quick
in
pointy,
here?
and then we're gonna keep
Okay.
going.
I was
Quick
going to
pointy.
say.
There's that flash chip that you saw
do we do new
before.
products still? 'Cause we
Huh?
have-
We could skip new products and just do it next week.
Yeah, let's do the new products next week and keep going because
Okay.
Yeah, this is-
I'll go quick.
I hope everybody's okay watching.
No, 'cause
I'm
I see
just
more-
personally
I see
so
more,
interested.
I see more things that you have here like testers. So
Yeah,
let's,
this is so
this
cool.
is the GoTenna hour.
So cool.
Welcome.
Thank
Yeah.
you.
Okay, what's this big circle?
That's an NFC antenna, but I kind of put that in, and I wasn't supposed to, but I couldn't help myself.
No,
It was just-
Raph,
yeah.
please.
But I don't think we're going to use it.
wants to say something.
What I was going to say is, I think the approach that Rev took is we it's
Put it on.
you want to, right? You want to put all the options on the table, such that if we believe that you'll add value to our product, we enable it, and it speeds up development time. We don't have to waste time spin another board.
That's right.
So all the features we can imagine is on that board right now.
Always
This
do-
isn't necessarily going to be the board that if you
That's
support
nice.
Kickstarter, which you totally should, because it's less now than it will be later. It's not necessarily the exact board that you're going to get. It's just, we are preserving optionality, like Jen said.
Okay.
All right.
Okay, cool.
Flash chip.
Flash chip,
CPU.
expansion, CPU.
Bluetooth.
BGA, huh?
Yeah, I've got to do BGA.
Harsh.
There's no room. It's 121 pins, and I'm using almost all of them. It's ridiculous.
Wow.
There's a Bluetooth chip.
NR52, 8.
Yeah.
Yeah.
Yep. There's
Where's
the
the Bluetooth antenna?
Bluetooth antenna is right under your nose.
This little thing here. Okay, so you went with a wire antenna because you don't need that much distance. You're like, whatever.
It gets 20 feet.
Yeah, but you just needs to go to your
Yeah.
phone.
You can stick a paperclip in a Bluetooth chip and it'll work.
These Nordic chips
Yeah.
are like amazing.
Yeah, piece of cake.
They're amazing.
There's the TCXO.
Yeah.
Right, that's the good one. This is a push button controller.
Where's the temperature sensor?
It's inside. It's all
Oh,
inside
really?
there.
Oh, it looks just like the standard crystal, but it's
It's an oscillator.
It's a dollar crystal, not a 10-cent crystal. All right, so it's
Yeah.
a TXO inside.
Yeah.
You can't tell. Okay, so
I know.
cool.
There's that's the transceiver.
yeah.
So that's the Silicon Labs chip.
Yep,
And
the
this is a
460.
just great big giant front end. So this has a power amplifier. It has an LNA. It has
Is this
antenna
from
diversity switch.
RFMD? What is the name of the company again? RFMD.
Yes. Yes, Corvo.
Yeah.
And
It's
so
interesting. They're not on like the radar until you're like googling for parts, and you're like, oh man, like you guys make all of the front
it
ends.
took me forever to figure out who these companies are.
I know. Well,
Uh,
yeah.
So
You did a good job.
I kept the path. You see, these are like really bunched up, and this is super clustered here. This is the whole like RF area,
Mm-hmm. Okay.
especially the receive path. I tried to keep that as close as possible so
Yeah.
that there was as little just garbage in the way.
Most parts L2
And then
Yeah.
out we go to the antenna.
You got a little. You just
There's that
gotta
antenna that
choke
we
on the
cut.
out, and that's it.
It's a little bit of a different shape, but you can see it's kind of the same antenna as what was
Oh,
what
too
I cut out
funny.
with.
Yeah, you're right.
pretty close.
Serpentine.
And then on the bottom,
bottom.
we have just your USB and your button.
What is this? A USB 3? What is this weird?
That's just USB. This is
Okay.
this
It's
one
just
is just one that
unusual.
we were testing out. We're going to use a slightly different one, but that's
It's
all
just
that is.
chunkier. So I was like, oh.
Yeah, it's just a USB micro, just like
Okay.
on an Android phone.
Okay.
And then there's just a bucket of test points everywhere for our test fixture.
And how many layers is this board?
This is a 4-layer board.
Not too bad. Nice. Nice work, Jen.
Yeah. And here's
Nothing wrong with a 6-layer board, but a 4-layer board is pretty nice for a BGA, especially.
Well, thank you. Yeah, it's a pain in the ass, but we
Pain
did
in
it.
the ass. What was your?
Because it's cheap.
What's your routing mills? What mil? 10, 10,
4
5,
and 4.
4, 4? Okay.
Yeah, except for the NFC antenna is 3 and 3, because I didn't really care if it worked.
Oh, that's
wanted
right,
to
because the
see-
NRF52 has the NFC client built in.
I can't have something like that put in front of me and not just like put it in.
You know,
It's-
it would be
it's
good for
painful.
authentication. I think that's what they put it in for. Like, you would authenticate your devices because, like, nobody can ever pair. Like, you never.
That was the idea.
Yeah. I think that's why they put it in there. Oh yeah, I see you have. Oh, these are so cute. I understand. It's like, why is it one single trace, but it's actually like 20 traces.
There's I think 5. Yeah,
All
and
spun
it's
around.
like you can almost not see it.
And does it actually? It works.
I don't know. I haven't gotten a chance to try it yet.
That's awesome. And then, what size are your drills on this? Do you remember? 10 mil.
No, that's 6 mil.
Did you have to do how did you escape the BGA? Did you just?
The escaping is all pretty much by my human imagination.
Okay.
So I figured it's so many pins on the thing.
You're like the
that-
Willy Wonka of BGA escaping.
Yeah, I
Okay.
just kind of did it.
Okay.
It's just like, put on like a podcast or something and just like go into a trance for like 4 days.
But you don't need that many pins, right? So you can use mostly the outside or the outside. Do you know what I mean? Like, did they make
that
it?
one is a solid array. So there's no holes or anything in the middle. It's just a 11 by 11 grid.
Yeah.
And I used about, I'd say like 88, maybe a little over 80% of the pins.
Really,
There's a lot of stuff happening on the RF chain. There's a lot of little tiny switches,
Oh, okay.
turning things on and off, changing paths. The GPS chip wants so many. The Bluetooth
Yeah.
chip wants so many.
Yeah.
The transceiver. There's just all the flash, the 2 different UARTs. There's USB.
This is an adorable little dev board. I mean, it is a dev board in a sense, right? I mean, like look
Yeah.
at all. You have all the wireless here.
If you're after hacking away, these are UART pins and 2 I/O pins and a ground and a connection to the battery. So
Yeah.
knock yourself out. I
Okay.
made
Okay,
it
what
big.
would you want someone to build that you didn't have time for that they can use the SDK? What is something you'd love to see? Because they're
Why don't you just
they're
share
asking and
I'd love to see something autonomous.
really.
Yeah, I think that'd be pretty cool. And I think you can do that with the SDK over the serial port. So you could actually stick another controller on there and then send this thing off and have it, I don't know, be like a numbers station, short range numbers station or something. I don't know. You'd come up with something.
Jen, how about you?
Well, RF is actually pretty much at the limit. Again, it's due to all the
You can
rules.
bit bang Ethernet on this or something. Come on.
Now, what will be nice, since a big challenge of a mesh,
Yeah.
mesh network is, SDK is more on the software side, right?
Yeah, well, I think
Now,
that's-
if
Yeah, hardware too though.
Hardware, yeah.
okay, yeah, that'll work. Maybe big challenge of mesh network is power. It's battery, because imagine you have to relay other people's message. One message turn into 10, 1,000, and so on. If
And
there's a
you're
way
holding
to
on forever
optimize
because
power,
you don't know. You might eventually bump into someone.
exactly, and then because you have to relay message all the time, that means you're constantly listening for message coming in. So if there's a special way of improving power performance,
Okay.
double the battery life, that'll be
I
awesome.
have one last question.
That wouldn't be FCC compliant, but that's okay.
No, that's experimental.
No, it is. It is FC.
Yeah,
we
the
just
rules are easier
make
now.
the power more efficient. We're not cranking up the power level. Power as in battery power, not
Yeah.
transmit
All
power.
right, so
And
let's
it's more efficient.
Yeah,
let's
I'm
start
really
showing some of
interested.
these testers because we only got like 5 minutes.
see it?
Wait,
You want
what's
to
that?
see it work?
Oh yeah, that would be nice too.
Okay.
Yeah,
Okay.
we're gonna see it work.
I'm going to take this thing and I'm going to stick it in.
Wait, it has to be under the
Oh yeah.
Yeah.
Hold on. Gotta reorganize this thing. Okay.
So I made a
this
bunch
is-
of
Just look at her test.
test fixtures. They probably
Ooh,
would,
nice.
right?
Yeah.
I think I might have taken
Fancy.
a thing or two out of one of your tutorials.
Okay. Clamp it.
Did you
Where's
get
the
those
caps?
clamps from us?
McMaster.
Oh yeah.
Yeah.
They're really nice. These
Yeah,
are
nice
nice.
clamps.
Yeah, they're for like woodworking,
Yeah.
I think, originally.
And
I think
testing
they call them like jig
testing
clamps.
mesh network stuff, I guess.
I don't
Yeah,
know.
woodworking and mesh network testing.
Okay.
Okay, so it's in there.
X marks the spot.
Yep. That's actually so that the LED that's on here doesn't blind.
I love this like super risky tester action you got here. You're like no protection diode, no polarized connector. You're
I wrote
just-
black and red on it.
Yeah, I mean, who's gonna mess that up? There's supposed to be a bucket of fun hanging out with this guy.
We've got more if we break them. Okay.
Show that under the camera.
So should I put this under the camera? Is that the
Yeah,
best way to
sure.
do this? So we got an app, and the app works great. The app team is super talented.
Okay.
I'm starting to talk like Donald Trump more.
No.
They're tremendous.
Not to be braggadocious or anything.
Yeah.
Huge.
Where is it?
Make mesh
I can't
great
remember.
again.
Make mesh
All
possible.
right, pair with a new GoTenna. Here we go. So, da-da-da-da-da. Okay, so now it's paired.
Oh, okay. Blinking fast.
Okay,
Great.
so this is you,
Hi.
and I'm going to turn on another one.
I really want to take out this connector and swap it around, and I know it'll kill me, but I just like.
It actually happened several times.
But I really, because it says black and red, and I'm like, well, what if
Well, what if
I put it the wrong way?
What is black? What is
How can you tell me that the red I see is the red that you see? Okay. All right, so we're together here. Okay, what am I doing?
This is, I'm a big gibberish
Okay.
messenger. Boom! Wow!
Okay.
Okay, you got it.
She's still in like.
Oh, is it
weird
still not-
pairing world here.
Yeah,
she
sorry.
Should just go to the contacts.
Contacts. Wait, okay,
Or,
hold on.
Sorry, so
Oh, and then-
sorry, we don't know how to use the Android app because we're all iOS users. Home. There.
And
Okay.
then shout.
Whoa.
You want to write me a message?
Yeah.
Write me a message. Okay.
Zomg.
Zomg.
And then I hit
Oh my
return.
God.
Hit the little
Or hit
paper
the-
airplane.
the paper airplane. Okay.
Womp, womp.
Wow.
There it is. See?
You got
it.
it.
Works. It's real.
Wow.
Yeah. That's it.
Hold on.
And these are phones without service, right? These are phones that these are not.
You know, that would really make this a more compelling demonstration.
These are demo phones at the office. These don't
Yeah,
even have
because it says
SIM chips.
emergency call only.
Yeah.
So yeah,
Wow.
these don't
So
have
these
service.
are phones without any service, and
That's
there
so
you go.
cool.
You just saw GoTenna Mesh working.
It's almost, you know,
Epic!
I know you didn't.
Yay, live demo!
Yeah.
Live demo, congratulations!
I mean, all those old phones, you kind of have a use for them now.
Yep. Yep.
Yeah. Okay. I want to squeeze in a couple questions before we give something away. This is great. Thanks for coming with hardware. That was really good.
That's so cool.
So
Working hardware too.
Yeah.
So there's lots of people that are interested in doing a Kickstarter. Since you have 2 successful ones, what's been the hardest thing about the first one and then the second one?
We actually didn't do Kickstarter the first time. We did do a pre-order on our own
Oh,
website.
right, sorry, it was
and so
pre-orders.
this is our first Kickstarter. But I think with Kickstarter, we are learning as we go. I think it's just about, we're doing it to build community. And, it really helps if you're able to show, working prototypes to press who will write about it, Otherwise, it's very hard to drive people to your page. There's so many cool projects on Kickstarter.
And it's a little easier when you have a working success already, because you're like, hey, this is just an upgrade. We're not like
Hopefully people, are convinced through the story that we tell on our campaign page that we've done this before. This is our first rodeo. We will get you product that works, because
not
we
your
have
first
before.
radio or your first rodeo.
Radio
It's not our first radio
She
or
gets
rodeo.
first to
This
say
is not your radio rodeo bounty castle.
So you're up to 1,500 backers or more, and then 278K. That's more than the 150K, your goal. So if you could wave a magic wand, what would you like to see this like?
Right now we have a stretch goal. If we can hit 400,000, we're going to make really beautiful, sleek black versions of GoTenna that will be limited.
I bought black ones of the first version.
Yeah, so you got the limited edition last year, and they were popular, so we set that as a stretch goal. But frankly, I'd love to hit that stretch goal and offer even more stretch goal things. And so we're thinking about some like software features that can make like a dashboard where you can see how many times someone's meshed through you versus, so that you can make mesh real, right? Because mesh is invisible, and so we need to make that magic something you can like be aware of, so that you can be excited about it, you can like be a part of it, and you can hopefully tell other people to like join the mesh as well, right? And mesh is useful even if it's just 3 people, right? But it can be, those blue sky possibilities are so exciting about building infrastructure for communication powered by people with regular phones, And actually, it's a really cool thing that we have that you can also do with the SDK is we have the first way that our parallel off-grid network communicates with the central network. So we just last week launched GoTenna Plus, which is a software upgrade to both devices, the V1 and the GoTenna Mesh, that among other things, it allows you to send messages. For instance, if we're all out without service, but I happen to say I have AT&T and all you have Verizon don't have service, you guys can send messages through me, through GoTenna, out into regular SMS. And so, the whole goal of the company is to create like off-grid resilient parallel communication, but it doesn't mean that we can't creatively plug into every, so backhaul, like that's something I'd like to see someone build through SDK. We're going to do some of that ourselves too.
Yeah, I got a digital ham radio, and what's really cool about it is you can do FM local, but you can also use they have an antenna on the Empire State that goes into the internet, and so you can actually do like ham radio to this repeater, and then it gets tunneled through the internet. It can like pop out in Germany.
That's awesome.
So it's on one hand it's like, okay, well that's like ham radio. It's not really ham radio anymore. It's kind of like a phone, like VoIP, but it's like you can still use it for point to point.
Right, but that's the whole point is that there's no single one kind of communication that will serve all needs. So the point is like, how can we build like a robust stack that can do different things? And my hope is that GoTenna starts being used by people not just when they're off grid, but potentially to do the things that GoTenna can do well, like local communication, even when you're on grid, right?
Yeah.
So.
Okay.
With time.
Well, that is our hour.
That was a full hour.
Thank you so much.
Was that fun?
Absolutely.
Yeah.
Okay.
Yeah, I always like playing with these things.
This is great. You guys have to really show this off and like. And
Yeah,
like
you did a lot. People said live
loved
demo,
it.
like that's, you did it.
People
like that.
loved
That's
it.
always
We
a
did
risk.
it.
It's always a risk.
Oh, was that a risk? That was not a risk.
Thousands of backers.
Like we said,
Now
not
in
our
your
first
hands.
radio.
Zero sweat.
Yeah.
Okay.
Well, we're gonna do a trivia question now because we have to give something away. Oh, do you want to show what you're gonna give away, Lamar? Or do you want to say what it is?
Yeah, we're gonna give away. Well, it's out, but it's we didn't get to talk about it, but I thought I would give it away anyways. And next week we'll give
And
it.
we'll
I was gonna
do
give
new
away-
products next week.
I was going to give away a Teensy 3.5,
Teensy
which is a
3.5.
new product. We'll
Paul
talk
was
about it
just
next
here.
week.
Heard about this yet.
But we're going to give this away. It uses the MK64FX512, which is a Cortex M4 Freescale processor that can do all sorts of crazy shit. Check out the product page for more info, and we're going to give away one of these.
Okay. Lady, what are the rules of the trivia contest?
Rules are, if you've won before, you can't win again. Only one winner per my lifetime. The first person to answer the question correctly, the way Phil wants to see it in one of the chats, wins the prize. If you don't win, it's okay. Please come again next week. But please don't cheat or give people answers. Or give everybody a chance. We're trying to make it so everyone can win a prize.
Are you ready?
Yes.
Okay. The question is, what was the name of the open source MP3 player that Ref worked on?
Oh, boy.
And if you Google for open source MP3 player, you've got to dig around a little bit. But what was the name of the open source MP3 player?
It's disappearing.
No, it's there. It's there.
Oh, it's
There's just
still
a
there.
lot.
There was other open source MP3 players that came out afterwards.
It's true.
Yeah. So
And before.
All
Okay,
right.
so-
the answer is not 42. Everyone always says
Raphael's
that.
open source MP3
Yeah.
player.
Let's see. XMMS. No.
It's a hardware MP3
Amelia
player.
Earhart. No. That's always a guess. It's always a guess. Let's see.
This one's a little tougher.
Not Rockbox.
Oh, there's so many.
Yeah, I'll show a photo. I don't think it says it on here anywhere. No, it doesn't.
Toothis. Is that site still up?
Yes.
Okay.
It's not. It's not. Yeah.
That's
the thing.
That's the third one.
Yeah.
Yeah, well, don't
But
mention
the,
what
but
it
the
is
name
then.
is the same. It's not Rockbox. So
What is this?
Not Fubar.
If you have any
not Rockbox.
super fans.
Not-
Everyone thinks it's Rockbox.
Not MP3s.
It's appropriately obscure. This is a hard question.
This one is actually pretty.
Not Tomahawk.
Should I feel
hard.
good or bad?
Maybe they should go to the website and maybe if they Google.
Oh,
on
here it
the website.
is. Congratulations, Kip. Daisy.
Oh,
You got
that's
it.
she got it. Yay!
Yeah, no,
Oh no, Caleb.
Caleb.
Caleb Kraft got it. Oh wait, Caleb.
Yeah, it's fine.
Oh, it's okay. Sorry, I thought
Caleb
I
got
didn't
it.
see it.
He's was an editor at Hackaday and also now works at Make. So I think that is fair. It is okay. He got it, Daisy.
It's okay. It's true. He is
got
a
it.
super fan of yours.
Eventually, somebody has to come through and yeah.
I think he wrote about it. That's fine.
Oh.
At some point.
Thank you.
Yeah. Well, you got fans.
Okay.
All right.
All right, Caleb.
Look, usually the trivia questions are answered instantly. I wanted to make it a little harder. So, all right. Well, thank you so much, folks. I like that we're doing this like once a year or so. Yeah. I can't wait to see GoTenna 3 on the next
Mars
holographic
Indiegogo.
crowdfunded site. I don't know what the future
Next
is.
fall.
Yeah.
Yeah.
Okay. All right. Well, thanks, y'all.
Thank you.
Thank you.
Okay.
Yeah. Special thanks to all the Adafruit remote folks, the folks here at Adafruit, all the folks that have been keeping the Adafruit engine going. We had a bunch of stuff going on this week. Thank you, everyone. And to play us out this week, besides a code, GoTenna, 10% off, and a picture of a cat, we're going to show a Maker Faire highlight video that we put together. So enjoy this, and this is from the Adafruit team that was at Maker Faire. So bye, everybody.
Bye.